Hello, fourth grade students, and welcome to the Digital Math Station. Today our main focus at this station is going to be how do we divide using repeated subtraction. We've really had a lot of practice with this, and I feel as though you're ready to play a bit of a game. But you've got to make sure that you pay attention to all of the directions so that you know what you're doing at today's Digital Math Station. So without further delay, away we go. This is the game that you're going to be playing. It's dividing a 4-digit number, and the game is called the Greatest Remainder Game. You're going to play with one other partner. You will take turns. You'll place your marker on the start box, and you will solve one of the exercises below. You do not need to go in order. Then, move your marker the same number of spaces as the remainder. So for example, if you have remainder 6, then you skip ahead by 6. The winner is the first player to reach the end. Here's the game board at the bottom. You can see that I have 2 separate game pieces because I'm going to use these as an example on how the game will be played. So I'm quickly transforming. I'm no longer your teacher, Mr. Panza. I am Dominic Panza. I'm a 10-year-old student in this 4th grade class, and I'm about ready to play against my partner. This is my game piece. This is my partner's game piece. So Mr. Panza, who is now Dominic Panza, is going to get to go first. The first thing I need to do is look at any one of these problems and select one I'm going to do. Then, on a separate grid paper or on your whiteboard, set up the problem, 1,219 divided by 6. Remember, I'm asking myself over here how many 6s by using multiplication, either by 1, multiply by 10, or multiply by 100. And inside, underneath the dividend, I will be subtracting. The only way I understand what I'm subtracting is if I know what to multiply first. So that is where we'll begin. Because this is such a big number, 1,219, I'm going to start by multiplying by 100. And rather than just take 100, I'm going to skip count by 6 in my head to see how many 100s I can take. 6, 12, then I stop because my answer's 12. If you're not sure what I was looking for, I was trying to reach the 12 that's inside my dividend, which means instead of just 100, I can actually take out 200. So I'm going to switch my answer now to 200. So I'm still multiplying by the 100's place value. I just doubled it because 200 can surely fit in to 1,219. I'll show you why. I multiply my 200 by however many I'm looking at, which in this problem is 6. I take my 6, I multiply it by 2, which is 12, and then I add in my zeros to get 1,200, which is a good number to start out because now when I'm on to my next part of the problem, subtraction, I take 9 minus 0, which is 9, and 1 minus 0, which is 1. I can continue subtracting 2 minus 2 and 1 minus 1, which gives me 19. And now I'm ready to either look at the 10s or the 1s. I'm going to look at the 10s first. And I know that I can actually fit in more than just one 10. So I'm going to skip count by 6 again to see how many 10s can actually fit in to 19. Only it's not skip counting by 10, it's skip counting by 6 because again, that's my divisor. 6, 12, 18, I need to stop right now. Why? Because I realize that I don't want to go over 18. If I did, I'd have a big number and that would be way too much. So instead of just 10, it's actually 1, 2, 3, or 30. 30 gets multiplied by 6, so I can figure out what I'm subtracting. 6 times 3 is 18. Ooh, I've made a mistake because I have to add in my 0, which means this actually isn't and should not be 10. Instead, I can quickly fix my mistake and say, well, I could certainly do 3 1s and just change it to 18, which is what I'm going to do. Which means there were no 10s in this problem. Now I'm ready to subtract. 19 minus 18 is 1, and I'm done because 1 is my remainder. As long as it's lower than 6, it doesn't have to reach 0. You have a remainder of 1. Now I take my 200 and my 3, which is nothing more than a number in expanded form, and I write it in standard form, which is 201. 201. But I cannot forget about my remainder, especially in this game, because my remainder 1 tells me how many spaces I move. Let's go back to my game board. With a remainder of 1, I now can take my game board piece, which again, remember, I'm playing with this piece, and move 1 space. Really, that's not all that many, but at the same time, I'm just trying to finish ahead of my partner here who's about to jump on the start space. So let's assume that my partner was also checking this problem. What they would do is they'd solve the problem together, and then you would use a calculator to check and make sure that I had it correct. If you have it correct, you can also use our multiplication method to check, which means I take my my quotient, which is 201, the answer to a division problem, and I multiply by my divisor, 6, and then eventually I'm going to add my remainder, 1. 6 times 1 is 6. 6 times 0 is 0. And 6 times 2 is 12. Drop down my 6, drop down my 0, drop down my 2, and my 1. Looks like I have this one incorrect, because I only got 1,206, and if I add my remainder, that's not going to be enough. If this happens in your case, you and your partner need to check with each other. I quickly recognize that I took my remainder and put it here. If I switch that, I'm going to see that I actually do have the right answer. Because my quotient shouldn't be 201 remainder 1. When I add 203, it should be 203 remainder 1. That's going to change my answer entirely. 6 times 3 is not 6, but it's 18, which means I drop down my 8. There's my 1. My 2 and my 1. 1,218 plus 1 is 1,219. I'm correct. So as long as you and your partner get the same answer when you divide, and then check it with multiplication, then you are able to move your piece the amount of remainder spots that it gives you. Let's do one more example before you play. The next problem I selected was 3,863 divided by 4. I start out by asking myself, well, how many 4s? And the way I can get there quickly is starting with my hundreds place value. How many hundreds, or 400s, as it may, fit into 38? Let's see. I'm going to skip count by 4 until I get close to, but not over, 38. Let's sing. 4, 8, 12, 16, 20, 24, 28, 32, 36. So when I go and I count my tallies, I recognize that not only 100 4s can fit in there, but actually 900 4s can fit in. And I finalize that answer by figuring out what I'm going to subtract by taking 900 and multiplying by 4. When I multiply 9 times 4, I get 36. But I can't forget to add in my zeros. Now that I have a number under the dividend, I can subtract. 3 minus 0 is 3, 6 minus 0 is 6, and 8 minus 6 is 2. I'm ready for the next step in the problem, which again allows me to see, should I take out 100, should I take out 10, or should I take out 1? If I multiply 4 by 100, that's going to be too large, so I need to move to the next lowest place value, which in this case is 10. Once again, I need to skip count to see how many 10s would actually fit into 263. In order to sharpen my focus, I just look at the first two numbers, 26, and skip count up to, but not over, 26. 4, 8, 12, 16, 20, 24, then I stop, because there are 6. So I change this one. There's not just one 4 that can fit inside 263, but there are actually 6 4s. And I know that's true because when I multiply 60 by 4, 6, 12, 18, 24, and then I add my 0, I'm going to be good to go. I'm ready to subtract. 3 minus 0 is 3. 6 minus 4 is 2. And then I need to see how many hundreds, tens, or ones fit into 23. But it's not just 100, 10, or 1. It's 400, 40, or 4. So let's see. Again, I can look at my ones. How many ones? 4, 8, 12, 16, 20. I don't want to go to 24. So I stop right there and I realize that it's not just 1, but it's actually 5. Now that I know that it's 5, I multiply that 5 by how many 4s I'm trying to fit in there. 5 4s, 5, 10, 15, 20, which is going to leave me with a remainder. When I subtract 23 from 20, I get 3. So now me and my partner have to add this expanded form number and create a standard form number, which is 965. In order to check, put 965 into a lattice board with your divisor of 4. Almost made the same mistake I did on the last problem. And remember to add your remainder after it, which would be 3, because we believe that our answer is a quotient of 965 with a remainder of 3. Notice that I haven't moved my game piece yet. So when I set up my lattice and check, I've got to see if I'm correct. And if I am, I get to move my space. 5, 10, 15, 20. 6, 12, 18, 24. Then 9 times 4 is 36. I used my finger trick in case you were wondering. Bring down my 0. 4 plus 2 is 6. 6 plus 2 is 8. And 3. Don't panic if it doesn't look exactly correct, because you still need to add your remainder, which means your final answer is actually 3,863. And that matches my dividend, which means I was correct. So I go back to the game board. I recognize that my remainder was 3, and I take my game piece and move it 1, 2, 3 spaces. So that's how you use repeated subtraction to divide and play our game. I hope that you're able to play this game with a partner. Keep in mind that your teacher's in the back of the room still reviewing this game or some problems, so your game must be at a whisper. Make sure you're following directions quickly and enjoy the game.